Hi all. Here in this video we'll discuss about the brief history of the atom. We know that it is John Dalton who in 1800 put forward a theory called as the Dalton's atomic theory, and according to the John Dalton, he says that the matter, it consists of small particles which are indivisible, and use the term atom. Right, so according to the John Dalton, matter, it consists of small indivisible particles called atoms. That's why this is called as the Dalton's atomic theory. But later on we found that atom is not the smallest fundamental particle. Rather, it can be broken down into smaller fundamental particles, smaller subatomic particles. And it is the Robert Millikan who first, from his experimental studies, explained that atom has a negatively charged particle called electron. And he found from his oil drop experiment method, the Millikan's oil drop experiment method, he calculated basically the charge which is actually present on the electron. And later on, when proton was also discovered, the Rutherford put forward another famous theory called as Rutherford's nuclear model of atom. And basically he performed an experiment in which he bombarded a thin gold foil by a beam of alpha particles. And from the Rutherford's gold foil experiment, he found that atom has a very small region that contains the protons, and electrons are actually revolving around the nucleus in circular orbits. So it is first time the Rutherford who discovered the nucleus of an atom and said that atom is spherical, and in the middle of the atom is a small nucleus that is occupied by the protons, and electrons with negative charge, they are revolving around this nucleus in the circular orbits. After the Rutherford, it was the Niels Bohr in 1913 proposed a different model of an atom, which is called as the Bohr's model of an atom. And according to the Bohr, he says that the nucleus contains the protons and the neutrons, and around the nucleus there are circular orbits in which electrons are revolving around the nucleus, and the energy of these orbits remains fixed. So these are the stationary orbits. There are a number of stationary orbits around the nucleus, and electrons are revolving around the nucleus in these stationary orbits. According to the Bohr, it says that this electron in the lower energy level, this is the first energy level here, this is the higher energy level. Electron in the lower energy level can be excited to the higher energy level by absorbing the energy which must be equal to the energy gap between the two shells. So electron from the lower shell can be excited to the higher shell by the absorption of energy. And here in the excited state, electron is unstable and it will return to this ground state by the loss of an energy. So electrons can be excited to the higher energy levels, and from the higher energy levels these electrons can go back to the ground state. This is the very important concept that was put forward by the Bohr. So according to the Bohr, within the different shells of an atom, you can excite electrons from lower energy levels to the higher energy levels. And as we move away from the nucleus, energy of these orbits, these shells, that keeps on increasing. So that means the lowest energy level is the one which is close to the nucleus, right? The first energy level here, N1, this is the lowest energy level. This is the N2, the second energy level, and then so on. You have third energy level and the fourth energy levels. Electrons, they can jump from low energy levels to the higher energy levels by the absorption of energy, and from higher energy levels they can return to their ground state by the loss of energy. And according to the Bohr, he says we can calculate the number of electrons that can be present in the different energy levels by the formula 2n square. So from the 2n square, you can calculate the maximum number of electrons that can be accommodated in a one orbit, in a particular orbit. Suppose here if n is 1 in the first orbit, you can have 2 electrons, and 2 in the second orbit, you can have 2 times 2 square, which is 8 electrons. So that means in the first shell you can have 2 electrons, in the second shell you can have 8 electrons, and N3 you can have 2 times 3 square, which is 18 electrons, and 32 electrons, and so on.